Hello everyone, I hope you're doing well. So in this video, we're going to discuss the use of Lambda functions in C++ and this video is going to be specifically related to programming contests and competitive programming. So all the discussion and all the usage of Lambda functions that we discuss here will be like more related to the programming contest aspects only and will not be discussing the other aspects of Lambda functions, right? So before starting with the video, I would like to request you all, if at the end of this video you find this video useful, or if you were able to derive any useful information from this particular video, then do consider dropping a like on this video, because it really helps the YouTube algorithm to understand that this video was actually helpful for the viewers and they really enjoyed watching this video. So just for the algorithm, don't forget to drop a like on this video. Let us discuss some motivation, like why do we actually need to study lambda functions and what is the use of lambda functions? Why is it important to use lambda functions and not just regular functions? So the first main use of lambda functions is that it helps you write clean code, right? What do we mean by clean code? I'll explain you it in a while. When I actually write some code and show you with examples, you'll be able to see how lambda functions help you prevent writing repetitive code, right? So the second thing is you can write your function, like the lambda function, inside your main function along with your main logic. So basically you have a main function in C++ and you can write your lambda functions inside that particular function along with your logic of the problem that you are solving. So like it really helps you so that you don't have to scroll through your code again and again. If you write a normal function or a regular function, you will have to go up and check what is written inside the function. Then you come back down in your main function and check what is the logic. So it really helps you to prevent that, and you have your lambda function as well as your main logic together, right? So these are the two main points that somebody would use lambda functions for, and this will really help you in solving problems. So like the topics that we are going to cover in this particular video are the use of simple lambda functions and the use of recursive lambda functions. So like these are not actually different, but right, if you discuss only simple lambda functions, you can like write it in an even shorter way. I'll explain you in a while what do I mean by this, but simple lambda functions are even shorter to write, and if you want to form recursive lambda functions, you will have to write some more code as well. So these are the lambda functions that you will generally use as regular functions. So we will also discuss its use to sort vectors. So till now you must be using some sort of a comparator function to sort vectors or arrays, but we will discuss how you can use lambda functions only to sort the vectors. And at the end, like this is very important that you might sometimes find it useful, that we can also change the default order of a set or a priority key, right? So like you know that the default order in a set is increasing order, so we can change the default order of a set, and you will see how it is helpful in solving certain problems. So we will discuss also this particular part. So if you want to study any of those parts, I'll like leave chapters in this particular video. You can directly jump to any particular part if you want to. So this is the last slide I am going to show you. All the other things that we see from now on will be live coding, and I'll share examples with you. So let us start straight away with simple lambda functions. How do we form simple lambda functions? So this is my code editor, and here what we'll do is, let us suppose that we are trying to create a simple lambda function. So I've taken two integers a and b, and I'm trying to take input in it. So let's say my function is get sum a comma b. So this is a very simple function that will return me the sum of a and b. So how do I write this function? So I can write auto get sum is equals to int a, let's say x, or int y, and I can write it like this. So I just have to return x plus y, right? So this will be the code. Now let me just write some input. So let's say 5 and 3 is the input, and when I run this code, you see 8 is the output, right? So what is essentially going on here is, this is an auto keyword, and we'll talk about this later, but this is how you define lambda function. You write the name of the function, you write an equals to sign. This is the capture clause. We'll discuss again what is it in a while, and this is the parameters that are being passed to the lambda function, right? So int x and int y are the two parameters that are being passed to the lambda function, and it returns x plus y, right? Now this particular auto keyword is used to automatically deduce the type of this particular variable, right? So in this case, this particular variable getSum is denoting my lambda function. So if I write auto getSum, it will automatically during the runtime determine the data type of this getSum variable, right? So I don't need to explicitly write what is this get sum. Otherwise, I'll need to write a special kind of like notation denoting that this is a lambda function. So if I write auto, I'll save some time and I'll be able to like this will automatically reduce the type of get sum during the runtime. Now these are the simple like variables that that are being passed to a normal functions as well. Now there is one more thing I can do. I can write it like this, right? So what does this particular part denote? Now inside a lambda function, since you have since the like return type of this particular lambda function is determined at runtime, right? So whatever this particular value is returning, right? So it is determined according to it. But what happens? There are multiple if there are multiple return statements, right? So with in case of multiple return statements, so for example, this is return x and y. Let's say there is some condition. I'm just writing pseudocode. So let's say there is some condition 1. And if it is true, then let's say I'm returning 0 0.0, 0 0.5030, and otherwise I'll return this. So you see, this particular data type is integer, this particular data type is float. So during runtime, my compiler will get confused that what is the actual data type of this particular get sum lambda function. So with the help of this particular keyword, by writing it like this arrow function and int, I am denoting that this lambda function is going to return int or an integer. So I am explicitly denoting that the return value of this particular function is going to be integer, right? So this is something you can use if you want to specify what will be the return type of this particular lambda function. Now let us talk about the capture clause, and this will really help you to see how you can save a lot of code while using this particular capture clause. So right now we have seen like how you can pass variables. Similarly, you can also pass some other variables as well. So let's say I'm doing vector int v of size 3. So let's say v of 0 is equals to a, v of 1 is equals to b, right? So let's say this is not returning something, and I'm also passing a vector int and v. So what I'm doing is I'm passing this vector v by reference to this lambda function. So I want that the sum of 0 and 1 is stored in 2, right? So I'm just doing the sum and storing it at position 2, and I want to print the element as position 2. So before like printing it, I also have to call the function getSum a, b and v, right? So now you see that the total answer will be 8, right? So what is happening is I am passing this vector v as a reference, right? And I'm calculating the total sum at position 2, and I'm just printing this v of 2 here. So this is the simple pass by reference. But if you have ever solved some graph problems, you will realize when you try to pass the graph adjacency list, you try to pass the visited vector, you try to pass some other vectors as well. So it is a lot to write here, right? So instead what you can do is you can capture it here. So this capture clause helps me to get this particular vector v from the main function. So with the help of this capture clause, you can capture any variable which has been declared in the parent function. So what do I mean by the parent function? So let's say this getSum function was inside the solve function. So solve function is the parent function of getSum lambda function. Now if I have declared a variable v as a vector in the solve function, then I can also use it inside the getSum function. And to use it, I just need to like capture it using and v. So if I just run this code again, you will see it still works, and you can see the answer is still 8 here. And let me just change the values. If I do 8 plus 5, the answer will get updated, right? You see, so this means that it is correctly passing the vector v, and this particular lambda function is capturing the vector v. Now I can also just ignore this v, and if I just write and, it will like capture all the variables that were inside my parent function. Now you have to be careful while simply using and, just because if you write and, then it will capture all the other variables. So if you are passing some variables here and you are also capturing some variables from the parent function, then you have to take care that they don't match with each other, otherwise there will be some conflict, right? So if I show you by running the code now, it will get updated and there will be no errors, right? So the answer is still 13 and we didn't get any errors, right? So what is a general way, the most general way to write lambda functions is you can write auto, you can write your function, and you can use the capture clause as you want. It is like you can always write and, just make sure that the variables that you are using inside the function and the variables that are declared in the parent functions are different. So let's say you declare some variable 1 here, then declare some variable 2 here, then declare some variable 3 here. You can explicitly write the return type here, right, like this, and you do some work, and at the end you can just close this with a semicolon. So it is very important to close this with a semicolon, otherwise it won't work, right? So this was the discussion for the simple lambda function. Now let us have a look at how you can use recursive lambda functions and why do we need to discuss it separately. So as I've explained when you use the auto keyword, it will get executed at the runtime, right? So what happens when I call the get some function inside it, right? So let's say I call the get some function, but since this was going to be executed at runtime, the data type of this keyword, I cannot call this get some function because the data type or the return type of this get some function has not been computed yet. So I cannot call a function whose return type has not been already known, right? This is my problem. So I need to explicitly write, instead of writing auto, I need to explicitly write what is the data type of this particular function. So let me just write some code now. So let's say we are going to print some series, right? So I have a integer n here as input. So I'm going to declare a lambda function. So this is how you declare it. Let's say it is series, it is importing something, it is capturing the variables, and let's say I am at position 3, there is no return time, this is the void function. This is how you declare a lambda function. So what you need to do is, this is a function keyword that defines that this is a lambda function, and you have to use this less than sign. Inside this less than sign, you will have some details about the lambda function. So the first keyword is the return type. I have written void here. You can, if the return type is int, you will have to write int like this, right? But let me just write it void for now. So now your bracket starts, right? So this will be the data type of the parameters that you are going to pass to the lambda function. So for example, here it was p. If it was int x and let's say some vector int v that I am going to receive, then I have to write integer here, and I also have to write vector int. I don't have to write the variable name here. I just have to write the data type that is being passed to my lambda function, right? So these are the things that you need to take care of. That first of all, you write function, then this particular less than sign, then the return type, and then you open the brackets, and inside the brackets you write the data types of the variables that are going to receive as parameters inside the lambda function. So once you close this both of the brackets, now the rest of the part is still the same. And now I can write my code here. If p is equals to 1, let's say I want to print 1 and I just return. Otherwise, I print p and I just call series of p minus 1, right? So this is what I'm going to do. Now I just call my series function at series of n, right? So let me just call it for 5. So as expected, it prints the series in the reverse order 5, 4, 3, 2, 1, right? So whenever you are using recursive lambda functions, make sure you write this particular thing, right? You have to declare that this is a function, then you have to write the return type, and then you have to write the variables that are being passed. Now let us instead of passing a variable, let us do something else. So I'll be using the variable n here, since this was importing n by itself, and I can use this particular n inside it also. So let me just write n here, and I'll be calling decrementing n by 1, and I'll be calling the same function again. So I don't have to use this here now. Okay, so I didn't update the variables here. So you see that the integer was returned here, right? And since I'm receiving no variables inside this, and this was declared integer here, that is why it's just showing some error. So I have to remove, and the variables that are written here and that are present as the parameters should be same, right? So now you'll see that it so it runs without any errors. Let me just change the value of n. If I change the value of n, now the value of n is 10. Let us see the output. So this is printing the series from 10, right? Now there is one more very important thing. If I import only n here, then you will see that this code is not going to work, and I'll explain you why this is not working now. So if I am importing n only, you see I'm importing n. Now this series function is also a variable that is declared inside the solve function. Now this lambda function has not imported itself now, so it cannot call itself again. So only when this is imported, it will work. So if I write it like this, it shows no error now, right? So but instead, if you want to save time, you can just write a single and this will import all the variables in the parent function. You just need to make sure that the variables that you're using inside the lambda functions should be different from the variables in the parent function, right? So this is how you can use lambda functions to recursively call any element. Now let us discuss the third part, how we can use lambda functions to sort vectors. Right, so this part is also very important, and till now you must be using comparator functions. So let me just declare a vector of int, and let's say the size is n. Then I'll take input in this particular vector, and like this. So what I want to do is I want to sort this particular vector. So I want to sort it from the beginning until the end, and I'm using a lambda function like this. Right, so this is how you are going to use the lambda function. Let me just print it first. Right, so this is the code, and let me just write 5 here, and 1 2 3 4 5. So I'm trying to sort this particular vector in reverse order, and I'm trying to print it. So you'll see the output, and the output is 5 4 3 2 1. Right, so this is the correct output that we were expecting. Now what is happening inside the code? So this is the simple sort function, and in here, like till now, you must be passing your comparator function. But instead of writing the comparator function, you can just write the lambda function directly inside here. So this is why they are actually called lambda functions, because we can use these as functions without writing their name. They are also called anonymous functions. So this is the actual use of lambda function. What I'm doing is I'm just this particular thing denotes that this is a lambda function, just like we were using a while before, and it will receive two variables a and b, since it needs since any sorting comparator will need two variables to compare, and I just choose those variables, and this is the thing that I'm going to return. I want to return true if a is greater than b. That means the first element will be always greater than the second element, right? And you can like write your sorting order in any way you want. So this is how you can use the lambda functions to sort vectors, right? So this is very simple. There's nothing much to discuss about. You just have to take care of the format. Since we have already discussed how we write lambda functions, this must be quite easy for you. You just have to increase write these square brackets and then write the variable's name, and inside here you can write your simple logic for comparing the values. Now let us discuss the last part of this particular video. In this part, we will discuss how we can use lambda functions to change the default order of a set or a priority queue. So basically both of the things are going to be the same. There's not much difference in set and priority queue. So we'll quickly discuss how we can change the order. So this was our previous code, and so for example, let me create some set of integers. So the way you do it is you just write declare type. So this is something that is included in the format. DECL type means declare type. So I'm going to pass my comparator function here, and this is going to be a set, and here also comparator function. So this defines what is the default sorting order, and this overrides the default constructor of the set, right? Now so let me just write it as this. Right, now what I do is I define my lambda function, so it will be equal to com, and I can take in some values, however it is not important, and I'll take the data types that I am going to receive, and the default order is a is increasing order for sets. So let me just return a is greater than b. Right, now I have to take some input in my set. So let us do for int I is equal to 0, I is less than n, I plus plus. I am going to create an integer a. I am going to receive input in it, and I am just going to insert it in my set. So let me just write some random values: 2 3 4 5 6 7. Right, these are some random values. I'm just making sure that they're all distinct. Yeah, so now I can just print my set for s. I'll just print I, and I'll just print a new line. Right, so this will help me to sort the elements in my set in reverse order. So there's some issue, I guess. Yeah, So as you can see in my lambda function, I didn't write a semicolon after declaring it. So it is very important that you include the semicolon, otherwise your code will not work. So you see now all the elements are sorted in reverse order, right? This is a set that I'm using. By default, the order of the set is in increasing order, but you see the set is sorted now in reverse order, right? So you see that I'm passing the variables as pass by value. So I can also pass by them reference, right? The only thing that you need to take care of is whenever you pass by reference, they will not work directly. You will have to write some keyword here. So you see that it is showing me some error. So I'll have to write a keyword constant whenever I'm passing the variables by reference. So it works now. But now the question is, if it is working by passing by value, why do we actually need to pass by reference? So this is going to help you whenever you are dealing with some complex data types like structs or classes, right? Whenever the data type of this particular set is another struct or another class or some kind of container, right? In that case, if you directly pass the variables, then it will consume too much time, because every time it will create a copy of that variable. So let us assume that I am creating a struct here and I am naming it to be important, right? So let's say it is my important struct and I am defining some value x here. Now, if it is receiving a data type of type important, right? So this is my struct that it is receiving like this. Oh, so let me just complete the code for now. So it is going to be important here. Now, if it is receiving some variable n, then I have to print important new data. Let's say new data, and new data dot x is equals to a, and I'm going to insert new data inside my set, and I'm going to print I dot x finally, right? So I believe that this code is complete. Let me just try to run it. So I believe spelling error is there, right? So I have to compare a dot x and b dot x. So it works now, and the output is also the same. Now the thing is, you would always want to use this particular AND operator, and if you're using a struct or a complex data type, then you would always want to pass your values by reference, just because if you pass it by value, it is going to create a copy of itself multiple times, and that might give you TLE or memory limit exceeded, right? It actually happens in some cases. So that is why I'm telling you, if you're using a complex data type, then always include this particular AND sign so that you pass it by reference, right? So this is something we have discussed related to a set, right? Now let us discuss how you can use this with priority queue. So if I'm declaring a priority queue, then let's say we have some integers, and the way you do it with priority queue is like this. So I have to create a vector of integers, and I also have to pass my comparator function. So it should be declare type, and let's say comp2, right? So again I have to write comp2 here. So auto comparison 2 will be like this, and it is receiving some variable a, it is receiving some variable b, and it is going to return a let's say greater than b. So let me just push it into my priority queue, and at the end I'll print my priority queue as well. So while pq is not empty, I'll just print pq.top, and I'll just print a new line here, and I'll just pop it from my queue, right? So you see that this should come in increasing order, I guess, right? So you see all the values are now arranged in increasing order. First of all, that there is no syntax error in our code, and our code is working absolutely fine, right? Now the second thing is, let us discuss first of all this structure or the notation that you are going to use. So first of all, you have to write the data type of the priority queue as usual. Now you have to pass a vector of that data type, right? So if it was some other data type here, let's say you are using the struct important, so you will have to pass a vector of important, right? So let me just write int here, and again integer here, right? Now what is happening is, the third type is declare type, and as in the like set, that this is the same thing that you will be doing. You will be declaring the type as comp2, and again you will be overriding the default constructor of the priority queue. Now since the default order, in the default order, the priority queue creates a max heap, that is the maximum element is present at the top. That is why if I try to reverse the order, it will have the minimum element at the top. If I return a greater than b, it will form the minimum heap, right? So this is just something with priority queue. This is not the same with set. So a greater than b will help me form the minimum heap, and if I do this, you see that all the elements are arranged in increasing order. So this is how you can use it with a set or with a priority queue. This particular last part will be very helpful to you in certain problems where you want to change the order of the set and or the way in which the elements appear in the set of the priority queue. So I hope that this video was helpful for you. And if you find this video helpful and you enjoyed the video, then consider dropping a like on this video, because it really helps the YouTube algorithm to understand that this video was actually helpful for you. And share this video with your friends. Till the next video drops, keep coding, stay safe, bye bye.